Hey guys, this is a medium difficulty GRE quantitative reasoning question. This is a quantitative comparison format question. Topic from which this has come, inequalities. We're going to be solving two quadratic inequalities and then basically determine which of these two quantities is larger. Obviously, with any quantitative comparison question, we got to judge whether quantity A is greater or B is greater, or both are equal, or the information will not let us determine which is greater, right? Those are our four answer options, which we'll look at it in the next slide. Start by reading the question. If x is a positive integer, this is a very crucial information to solve this question in particular, but whenever it is presented, have this idea in mind, right? We're not going to look at x, which is 0, x, which is non-integer, x, which is negative. We're looking at positive integer x. So x can take values which are 1, 2, 3, 4, and so on, right? Now, based on this information, they're saying quantity A is the largest solution to this inequality. Quantity B is the smallest solution to this inequality. Let's start by solving each of these inequalities in quantity A and quantity B, arrive at the solution, and then for the first case, let's pick up how high can this value be, and for the second case, let's pick up how low can this value be, given the fact that x is a positive integer. Start with the first one. Going to factorize this. These are the four answer options. Quantity A is greater, answer is A. Quantity B is greater, it's B. The quantities are equal, then it is C. If you cannot determine, you do not know which is greater, then the answer option is D. Start by solving the inequality in quantity A. 2x square minus 7x plus 6 is less than or equal to 0. I'm not going to go in depth into why this is happening. I'm just going to focus on the how in terms of solving this. The first part is factorizing this quadratic equation. The product of the coefficient of x square and the constant term, which is a 2 times 6 plus 12. We need to break this minus 7 into two parts so that the sum is a minus 7x and the product is essentially this 12x square. So factorization works this way. 2x square minus 4x minus 3x plus 6 is less than or equal to 0. So sum is minus 7x, product becomes 12x square, which is the product of the first term and the last term. 2x is a term common to the first and second terms. So 2x if I take out, I'm going to have an x minus 2. Take the minus 3 common out from the third and the fourth term, you'll be left with a x minus 2. Minus 3 into x is a minus 3x. Minus 3 times minus 2 is a plus 6, less than or equal to 0. X minus 2 is common to both these parts. So you'll have x minus 2 times 2x minus 3 is less than or equal to 0. So this is the factorization we have. I'm going to quickly tell you what the rule is and move on. I'm not going to say why the rule is working the way it's working. If we have a inequality of the form x minus a times x minus b is less than 0, we have a less than or equal to, we'll come to that in a while, less than 0, then essentially the value of x will lie between the two roots. Let's for a moment think of a to be the lower value and b to be the higher value. What are the roots for us? The roots for us are basically equate this to 0. X is equal to 2 is one root. 2x minus 3 equals 0. If you equate it to 0, you will get 2x is equal to 3 or x is equal to 3 by 2. So the values of a and b for us are 3 by 2 and 2. Right. So the inequality, the value of x will lie between the roots. One root is 3 by 2, which is 1.5. The other root is 2. So x lies between this. It is not a strict inequality. It's a less than or equal to. So it can take values which are 1.5, including 1.5 and 2. So what are the range of values that x can take for this inequality? It can start from 1.5, 1.51, 1.5111, so on and so forth, 1.999, and then 2. It can also include a 2. What are we trying to find out? The largest solution to this inequality. How high can it be? It can be as high as a 2. And x is a positive integer. Is 2 a positive integer? Certainly yes. So the quantity A value is equal to 2. We solved the inequality. We found a range of values that will satisfy this inequality. We're picking the highest value and checking whether that highest value is a positive integer. It is. Can it include a 2? Yes, basically because this inequality is not a strict inequality. So quantity A, the value is 2. Done. Pause the video here. Try and do this for quantity B and then come back to the video. Did you guys finish it? Let's have a look at it. Let's solve the second inequality. This is a greater than inequality, so let's solve it carefully. Product of the first and the last term is 30x square. We need to break this 11x into two parts so that the sum is a minus 11x and the product is a plus 30x square. Obviously, you would have figured it out by now. It's a 6 and a 5. So 3x square minus 6x minus 5x plus 10 is greater than 0. Take 3x common from these two terms, that will leave us with an x minus 2. Minus 5 common from the third and the fourth term, that will leave us with an x minus 2, right? Minus 5x plus 10. X minus 2 taken common from both these parts will leave us with 3x minus 5 is greater than 0. So the roots are essentially 2 and 5 by 3. 5 by 3, 6 by 3 is a 2. 5 by 3 is obviously a number which is greater than 1 but lesser than 2. So what do we have here? Greater than inequality. So I'm going to write the rule directly. X minus a times x minus b. If you recall the last time, it was less than 0, so it was lying within the roots. If it is greater than 0, then it will not lie within the roots. So if a is smaller than b, let's say these are the roots, then it will not lie between the roots. It's going to be a value which is lesser than a or a value which is greater than b. So what is the lower root for us? Lower root for us is a 5 by 3. So the values of x will be essentially a number which is lesser than 5 by 3 or a number which is greater than 2, right? It will not lie within the roots. It's not going to lie here. What are we looking at? The smallest solution to the inequality. Smallest solution to the inequality can take values which are lesser than 5 by 3. How low can it go? It can go as low as minus infinity. So we'll say that, come on, hold on is what you're saying. Minus infinity is the lowest value. But before we sign up with that, we know that x is a positive integer, which means that negative spectrum is ruled out. Even 0 is ruled out. Numbers like 0.5 are ruled out. 5 by 3 is what? 1.66, 1 and 2/3. We're talking about x being a positive integer, which is smaller than 1.66. What value can it take? It can take a value of 1. So the smallest positive integer solution to this inequality is when x is equal to 1, right? X does not lie between 1.66 and 2. It can take values greater than 2. So how high can it be? Infinity. But we're talking about the smallest solution. How low can the smallest solution without this condition be? It can be as low as minus infinity. But with a condition thrown in that it's a positive integer. Any positive integer lesser than 5 by 3, how low can it be? The lowest value that it can take is essentially a 1. So 1 is the value for quantity b. Let's go and look at what value we got for quantity A. It is a 2. So let's do the comparison now, and now we have the answer. The largest positive integer solution to the first inequality is a 2. The smallest positive integer solution to the second inequality is 1. Obviously, quantity A is greater than quantity B. Choice A is the correct answer to this question.